All right, so we're back to the notes packet that you got at the beginning of the year, and we're going to talk about slope and the relationships between lines. So get yourself ready to take notes, get that packet out, and we're going to get started. So slope is something that's true about lines on the coordinate plane. So you'll see some graphed pictures right here. And slope is a measure of how steep the line is. So here we have what's called a positive slope, just like positive correlation, it's going up. Here we have a negative slope, it's going down, just like our negative correlation. And what we can do is we can talk about how its slope and how steep it is. Like this is a very steep line going up, but we might also have one with a smaller slope, which would look something like that. Now the way we calculate slope is as a fraction. So slope is equal to rise over what's called run. So the rise is the amount that it goes up and down, and then the run is the amount it goes left and right. So if I'm looking at this picture here, I have 2 points highlighted on my line in number 1, and the rise then is the difference this way, and the run is the difference this way. So we can see that that's how we're going to go between this point here, which would be 2, 1, just as practice, and this point here, which would be 4, 7. Now, our rise here, we go up 1 space. You're counting the spaces, not the lines. So 1 space, 2, 3, 4, 5, 6. So here we would say our rise is equal to 6, and our run is 2 spaces. So then our slope in this problem, and here's just a weird thing that is used, is slope is always represented with the variable m. Do I know why? No. Does it kind of annoy me? Sometimes. But it's always going to be true in every algebra class you ever take. So we get used to it. M, the slope, is equal to, again, rise over run. So that's 6 over 2. Rise, run. And we simplify that to 3. So it tells us 3, it's not the steepest line ever, but it's positive and it's pretty steep. There's many much smaller fractions than that. So in that case, our slope is 3. Now, if I'm looking at this line over here, the negative one, I'm going from this point here, which is x is 1, y is 7, to a point down here, which has an x value of 6 and a y value of negative 3. So in terms of my rise, I'm actually going down, and this is why you could have a negative slope, is that in this case the rise is negative, and it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rise is negative 10, and the run, we're going in a positive direction. Here's our positive. So we're still going positive for our run. You can count it in either direction, but you have to pay attention. Positive x, positive y, negative, negative, what direction you are going. And the run here is space 1, 2, 3, 4, 5. Positive 5 because we're going in a positive direction. So then our slope, m, is rise over run, negative 10 over 5. Again, here's our rise, and it's negative because it's going down. Our run is moving in a positive direction. And our final slope answer is negative 2. Now, one thing that's super helpful is sometimes you're not going to have the picture like this. You might just have these x and y values. And you can still calculate that problem using a formula. You can say that the slope is equal to what we call the difference in the y values. So your second y value minus your first y value. So that's your rise, because that's the difference in our vertical direction. And our run would be the difference in the x values. So where x1, y1 and x2, y2 are points on the line. Right? So again, difference, so that's be subtraction, difference in y, and difference in x. One thing that is important is that you can pick which point is your first point and your second, but they have to stay in a line. So like these two go together and these two go together. Otherwise, you're going to get weird things with your negatives. So another type of line you might have as a graph is horizontal and vertical. And if we're looking at a horizontal line like what we see here between CD, this line doesn't have any rise at all. So the slope of a horizontal line has 0 rise, and then whatever the run is this distance between whatever 2 points. But as we know, 0 over anything, right, this is our division property of 0, is 0. So horizontal lines always have a slope of 0. So I can say the slope of the line CD, which we then show as a line by putting arrows above it, is equal to 0 because it's horizontal. Now, a vertical line, like we see here with AB, has no run, but it always has some rise. It's going up. So in this case, our rise is however distance between those points are, but the run, it never goes left to right. And as we hopefully remember, this is DNE. It's undefined. And if you have trouble remembering it, here's what I always say is that if it's horizontal, so if we're looking at some horizontal lines, that means it has a slope of 0. See how the letter Z has 2 horizontal lines in it? Versus if it's vertical, it has no slope. And N has 2 vertical lines. So helpful way for you to remember. So then in this case, M of the line AB does not exist. It's undefined. Lastly, we're going to talk about parallel and perpendicular lines. Now, important fact about parallel lines is that they will have the same slope. If 2 lines have the same slope, you always know that they are parallel. If they have perpendicular lines, meaning that they meet at a right angle like this, that means that they have what's called opposite slopes. And there's 2 ways to be opposite in math, and these are both. So it means that it's got the negative is different. So one's positive, one's negative, as you can see in the picture, and it's the reciprocal. So if we're thinking about a fraction, one example would be if I have a line with slope 2/3, the perpendicular slope would be negative reciprocal 3/2. Now in number 3, we're asked if these lines are perpendicular or not, because they kind of look like it, but we can't be 100% sure. So I'm going to try for line A first, and I'm going to use the formula just so that we have practice with that. So line A, the slope is equal to, here's my 2 points on line A. So I'm going to call this point here my first point. I'm going to call this one here my second. And so I'm going to start by saying, okay, I've got -4 as my y value for that point, and -3 is my x, minus 4 and 2. So I'm just using the numbers from these points. The first one's the x value, the second one's the y, nice alphabetical order. -4 minus 4 is -8. -3 minus 2 is -6. And so what I will do there, oh, not -6, I apologize. That is -5. Goodness me. So Then what I'll do is just cancel out those negatives, and it's 8 over 5. Now the question is the slope of b negative 5 over 8? Well, we'll have to see. I'm going to do the same thing. I'm going to look at the 2 points on b, which here is negative 3, 0, and here. So my slope for b, m is, and I'm going to call this my first point, and this one's my second. So my second y value is negative 6 and 5, minus my other set, which is 0 for y, and negative 3. So again, we're just using x, y, x, y. Negative 6 minus 0 is negative 6. 5 minus 3, like this, is going to become plus, so this is 5 plus 3. So now I have negative 6 over 8. So close, right? These are not perpendicular because we've got a 5 here and a 6 here. Otherwise, they are so close, but not quite. Slope is a really big concept in this year of math. So please go through things carefully and let me know if you have any questions, because this is an idea that's going to show up time and time again. Talk to you later. Bye.